Pleural refers to the space between the chest cavity and the lungs, and effusion refers to a collection of fluid. So a pleural effusion is when a disease process causes fluid to start to collect in the pleural space, which can sometimes restrict lung expansion. Now, the pleural cavity or pleural space lies between the parietal pleura, which is stuck to the chest wall, and the visceral pleura, which is stuck to the lungs. Because the lungs fit snugly inside the chest cavity, the visceral and parietal pleura lie right next to each other, and the very, very thin space between them contains a layer of fluid that acts as lubrication to allow the lungs to slide back and forth as they expand and contract. This pleural fluid is similar to interstitial fluid, and is made slippery by proteins like albumin. It's so similar to interstitial fluid because it essentially is interstitial fluid. There's always a tiny bit of plasma that leaks out of capillaries and gets into the interstitial space. And since these capillaries are so close to the edge of the pleural space, that fluid makes its way into that space and collects there. If there were no way out of the pleural space, then it would just fill up with fluid. But fortunately, there are lymphatic vessels in the pleura that drain the fluid away and deliver it back into the circulatory system. A pleural effusion is when there's excess fluid in the pleural space, either because too much pleural fluid is produced by the body, which could be due to a transudative or exudative effusion, or because the lymphatics can't effectively drain away the fluid, called a lymphatic effusion. A transudative pleural effusion happens when too much fluid starts to leave the capillaries, either because of increased hydrostatic pressure or decreased oncotic pressure in the blood vessels. Hydrostatic pressure is what we normally think of as blood pressure. It's the force that blood exerts on the walls of the blood vessel, and can be thought of as a pushing force. A common cause of increased hydrostatic pressure in the lung capillaries is heart failure. That's because when the heart can't effectively pump blood to the body, it backs up into the pulmonary vessels and causes the blood pressure in those vessels to rise. This high pressure forces fluid out of the capillaries and into the pleural space. Oncotic pressure results from the inability of solutes like large proteins, like for example albumin, to move across through the capillary. By osmosis, and talking about the process, not the company, fluid moves from areas of low solute concentrations to high solute concentration. Fluid therefore flows out of the capillaries and leaks into the pleural space when there's a decreased oncotic pressure in the blood vessels. Two causes of low oncotic pressure are cirrhosis, where the liver makes fewer proteins, and nephrotic syndrome, where proteins are lost in the urine. An exudative pleural effusion is due to inflammation of the pulmonary capillaries, which makes them a lot more leaky. The larger spaces between endothelial cells allows fluid, immune cells, and large proteins like lactate dehydrogenase, or LDH, which is found in all cells, to leak out of the capillaries. The causes of this, though, can vary, and include things like trauma, malignancy, an inflammatory condition like lupus, or an infection like pneumonia. If the underlying reason is an infection, like a bacterial or mycobacterial infection, then it's also possible for that infection to spread into the pleural space, which is a walled-off space, kind of like an enormous abscess. Just like an abscess, the infected pleural space can develop fibrinous walls and have loculations. Finally, there can be a lymphatic pleural effusion, called a chylothorax. In a chylothorax, the thoracic duct is disrupted, and lymphatic fluid accumulates in the pleural space. The most common cause of chylothorax is when the thoracic duct accidentally gets damaged during a thoracic surgery. But it can also be caused by tumors in the mediastinum that press up against the thoracic duct and compress it shut. Symptoms of a pleural effusion mostly depend on its size. A small effusion might go unnoticed, whereas a large one might cause pain while inhaling, called pleurisy, as well as shortness of breath, and might be more obvious only when lying down flat. Classically, a pleural effusion will cause decreased breath sounds, dullness to percussion, which is tapping on the back, and decreased tactile fremitus. Tactile fremitus is a normal finding. It's when the chest wall can be felt vibrating when a person speaks. If there's excess fluid in the pleural space, though, it absorbs some of this vibration energy, and the vibrations can't be felt as strongly. Finally, if the pleural effusion is large enough, it can start to push against the lung, not letting it fully aerate and even causing the trachea to shift away from the side of the effusion, called tracheal deviation. On an X-ray taken of someone standing upright, the pleural effusion fluid can settle into the costophrenic angle, which is where the diaphragm meets the chest wall, and cause blurring of the angle as fluid displaces the air that's usually there. On an X-ray taken of someone lying down, gravity will cause the freely mobile pleural effusion to settle along the chest wall, creating a layering effect. To get rid of the pleural effusion fluid, both to relieve symptoms but also to find out the cause, a thoracentesis can be done. In a thoracentesis, a hollow needle to drain the fluid is carefully inserted over the top of a rib to avoid injuring the neurovascular bundle running along the underside of each rib. Transudative fluid looks clear. Exudative effusions are full of immune cells and therefore look cloudy. And lymphatic fluid is filled with fats and looks kind of like milk. Often the biggest challenge is distinguishing between a transudative and exudative effusion. And the key difference is the amount of protein in the effusion. Exudates have much more. To help with that distinction, there are criteria called the Light criteria. A pleural effusion is considered exudative if the ratio of pleural fluid protein to serum protein is greater than 0.5, the ratio of pleural fluid LDH to serum LDH is greater than 0.6, or if the LDH in the pleural fluid is more than 2/3 the normal upper limit of normal levels in the serum. Although this isn't part of the Light criteria, another feature of exudates is that they typically have a pleural fluid cholesterol level of over 45 milligrams per deciliter. Treating a pleural effusion typically means removing the fluid as well as treating the underlying cause, and the approaches can vary quite a bit. Small transudative pleural effusions resulting from heart failure might be treated with diuretics and sodium restriction, whereas larger pleural effusions due to an oncologic process might require draining with a tube. Finally, there might be a large, loculated pleural effusion caused by bacterial pneumonia or tuberculosis, which might need surgery because it can thicken into a paste-like substance called an empyema, which wouldn't drain easily through a tube. Alright, as a quick recap, a pleural effusion is when fluid collects in the pleural space around the lungs, restricting expansion and causing pain and difficulty breathing. Pleural effusions can be due to excess fluid collection, either transudative or exudative, or due to blockage of lymphatic drainage. Diagnosis is usually done with a thoracentesis, which can help alleviate symptoms and can be used to identify the underlying cause.
Hey guys, Vince here. I hope you found our video today on pleural effusions instructive. Today's script was written by Krista Morris, it was edited by Rishi Desai, Dana Marshall performed the voiceover, and I created the illustrations. If you'd like to support the creation of more of these kinds of videos, check out our website at osmosis.org, where you'll find flashcards and quizzes and scheduling tools and other great stuff that'll help you learn medicine. Otherwise, you can subscribe to our channel on YouTube, follow us on social media, or donate to us on Patreon. All right. Thanks a lot, guys.